Hello everyone, this is Dr. E, and for today we're going to be working with real numbers and how we apply this in real life situations. Answering word problems is probably one of the most challenging skills that we need to learn in mathematics. And for today, we're going to be using real numbers as our numerical values that we're going to be operating with to be able to be more confident in answering problems in algebra of this set of numbers. So real numbers, they are numbers that are in decimal form or in fraction form or in positive and negative form. So we're going to be using them, and we know that when we are working with word problems, it's important that we know how to translate our verbal statement into its numerical form, and we're going to practice some of these terms or vocabulary that we are using in mathematics that we'll be able to need, or we're going to be needing, so that we'll be able to answer problems that we're going to be tackling for today. Now, opposites or additive inverse in mathematics will be the two numbers that are the same distance from zero but lie on opposite sides of zero. So when we hear the word opposite or additive inverse, you're just simply switching the signs of your number to get its additive inverse. So let's say we're looking for the opposite or additive inverse of 9, 3 over 4, and negative 3.5. Opposite, just like some of my students are having confusion on, it's not the same as reciprocal. So opposite is basically a sign switcher. So that means if we're looking for the opposite or additive inverse of 9, it will be negative 9. And we know that this is the additive inverse because if we add 9 and negative 9, it will equal to 0. So that is the additive inverse property that is being showcased when we choose the opposite of a number. So if the opposite of the or if we're looking for the opposite of 3 over 4, its opposite is not 4 over 3, but negative 3 all over 4. So this is, again, if we add 3 over 4 minus 3 over 4, it will equal to 0. And negative 3.5, its opposite is going to be positive 3.5. And now that we are a little bit more familiar with the real numbers, and real numbers are numbers of this form, we're going to be seeing them in answering word problems like this. So Sandy is 5 years older than 1/3 of Liam's age. If Sandy is 16 years old, how old is Liam? So in this case, all we need to do is to translate our verbal statement into its algebraic form, and we're going to start with 5 years older. And 5 years older in algebra is translated into plus 5. And the next statement that we're going to be processing would be 1/3 of Liam's age, and the word of is associated to the operation of multiplication in algebra. So 1/3 of Liam's age is going to be 1/3 times Liam, or 1/3 Liam. So now that we are translating it into its numerical form, we can now translate the description of Liam's age in algebra, and that is going to be 1 over 3 L plus 5, where L, of course, is represented by Liam. So now that we have our description for Liam's age, which is 1/3 L plus 5, we're now going to start working with our equation. And the equation is going to be completed because Sandy is 16 years old. So the word is associated or can be translated into the equal sign in mathematics. So now our equation will be 1/3 L plus 5 equal to 16. And now that we have an algebraic equation, 1 over 3L plus 5 is equal to 16, where L, of course, is Liam's age, we are going to use algebra to have L by itself. And using our skill that we have learned in the property of equality, we are just going to take the additive inverse of 5, so we can cancel this out. So we have 1/3 L equals 16 minus 5 is 11. And when we see a fraction 1/3, all we need to do is to multiply both sides by its reciprocal, not opposite, but reciprocal, which is 3. And by doing so, 3 times 1/3 is equal to 1. So now we only have an L equal to 33. So this is Liam's age according to how it's been translated to algebra. So that is how we use our algebra skill and our familiarity with the use of the real numbers to be able to answer basic algebra questions similar to this one. So let's make use of those real numbers again in this problem. So Ben bought one share of stock at 40 points. He watched the price of his stock every day for a week. Now on Monday, the stock moved 2.5 points up. On Tuesday, it moved 1.75 points down. On Wednesday, it moved P points. And on Thursday and Friday, the stock moved 0.75 points up each day. Now, if the price of the stock was 45 points at the end of the week, what is the value of P? So we are looking for the value of P. So all we need to do is to translate the statements from its verbal form to its numerical form. And the first statement that we have here is that Ben bought one share of stock at 40 points. So he bought it, so it will be positive 40 points at the beginning. And then the next statement we have, on Monday, the stock moved 2.5 points up, so it will be plus 2.5. And then we have, on Tuesday, it moved 1.75 points down, so it's negative 1.75. And on Wednesday, it moved P points. And P points is the description that we're going to be looking for in this word problem. So we're just going to put plus P for this statement. And on Thursday and Friday, the stock moved 0.75 points up each day, so we can translate this statement into a multiplication operation. So for 2 days, it moved constant at 0.75 points, so we can use 2 plus 0.75 for this expression. And we know that the price of the stock was 45 points at the end of the week, so all we need to do is to equate this numerical value to 45, and now we have our equation that we can solve so that we can find the value of P. So now that we have our equation, we can now use the order of operation to be able to solve for this problem. So the first step that we're going to do is, of course, the operation of multiplication. So we will multiply 2 and 0.75, and now our equation will be this form. So now that it's simplified to 40 plus 2.5 minus 1.75 plus P plus 1.5 equals 45, the next move would be to add 40 and 2.5, and 40 plus 2.5 is 42.5. And now we can proceed to left to right technique, because all the operations that we're seeing is just addition and subtraction, and this falls under the case 1 category based on our previous lesson on order of operations. So now we can just subtract 42.5 and 1.75, and we'll have 40.75, and from here we will combine 40.75 and 1.5 so that P will be by itself. So we're simply combining like terms so that we will have an equation similar to this one, which will help us in answering our algebra problem. So now we have 42.25 plus P equals 45. We can easily find the value of P by finding the additive inverse or opposite of 42.25, which is negative 42.25. And by doing so, we can now subtract 45 and 42.25, and the difference between them is going to equal to 2.75. So now we're able to solve our stock market problem based on the order of operation and the real numbers that we are using. So the stock moved up 2.75 points from this problem. So this is how we use our real numbers. So let's move to the next word problem, and this is going to be problem on DVD. So the selling price of a certain DVD is $7, or $7 more than the price the store paid. Now, if the selling price is $24, what did the store pay? So our keyword here is more than, and we're going to be using that in translating our verbal statement to its numerical form. So the phrase or the phrase $7 more can be translated to plus 7, and the selling price is $24, and is the equal symbol or equal sign symbol in our translation in algebra. So now we can construct our algebraic equation into x plus 7 is equal to 24. And the x that we're looking for is the amount of money that the store paid for this price. So if we have x plus 7 equal to 24, additive inverse of 7 is negative 7. And by doing so, we cancel out the 7 because it will turn to 0. So x is equal to 17. And this is how much the store has paid for this transaction. So using our real numbers and using algebra, we're able to solve our word problem. And that is why we need to be familiar with the use of those sets of numbers, because our numbers in real life is not limited to positive whole numbers. So for our number bender challenge of the day, see if you can solve how many weeks will Narda need to save to have enough money for this particular trip. And this is our lesson on real numbers and how we use real numbers in solving word problems in algebra. So remember, the key is to be able to learn how to translate our verbal statement into its numerical form, and how to be more comfortable in using real numbers or numbers that's not limited to just positive and whole numbers in solving math problems like what we had in this lesson. This is Dr. E, and see you again next time. Bye!